Example 19.9 is going to ask us to evaluate or simplify each expression without a calculator. And we saw this example, a type of example like this earlier in the section, but now we're going to be working only with the common log and the natural log, just to get you familiar with those. So we have on our first statement log of 1,000. The approach will be the same as we did earlier in the section. I'm going to set this equal to a question mark. But when I do this, I have to make sure that I remind myself that there is a base of 10 that is implied, and then the 1,000 represents the argument. So as I rewrite this, I'm going to get 10 to the question mark equals 1,000. And then there's only one exponent that will make that true. It is 3. So therefore, log of 1,000 is equal to 3. And I would encourage you to check the work here with the calculator, although I want you to do the practice without the calculator. Go back and plug it in and see that you can get this to work properly with whatever calculator you own. All right, next example, part B. We have log of 10 raised to the 8. The 10 raised to the 8 is the argument, but there's also an implied 10 for the base. Set that equal to the question mark, and then we have 10 raised to the question mark has to equal 10 raised to the 8. And the only way that that statement can be true is if my exponent is 8. I have to make sure the left and right side look identical. So therefore, log of 10 raised to the 8 is just going to be equal to 8. Part C, we have the natural log of 1 over e to the 6. 1 over e to the 6 represents the argument, but there is also an implied e for the base of this natural log. So when I set this equal to my question mark, I'm going to use the base e, question mark will be my exponent, and then 1 over e to the 6 is going to represent my my argument there. So now I think about what kind of exponent is going to make this work. And the only kind of exponent that's going to make this work is one that's negative, because we have the 1 over e to the 6. That's the reciprocal. And if I need 6, then I obviously am going to have negative 6. So therefore, the natural log of 1 over e to the 6 is going to be equal to negative 6. Again, I encourage you to check these in your calculator, see that your log is working properly and you're using the parentheses as needed to be able to represent your statement. Let's go on to part D. E to the natural log of 325. So this is not a logarithmic statement like the others are. This looks more like an exponential statement. So we have e representing the base, the ln of 325 represents the exponent, and then that means my question mark represents the argument. So when I convert this into a log form, I'll write log base e, question mark for the argument, and it's all equal to the exponent. So I write down ln 325. On the left-hand side of this statement, I have log base e. We were told that log base e is the same as ln. So this is really saying ln of something is equal to ln of 325. So therefore, the argument on the left needs to look just like the argument on the right. So that means the answer must be 325. So I'll state, therefore, e to the ln of 325 must be equal to 325. The next part, part E, is going to be done similarly. This is an exponential equation once I set it equal to the question mark. And if I rewrite this, I would say log base 10 question mark is my argument, and then it's all equal to the exponent, and the exponent happens to be a log, and it's log of 9x. On the left-hand side, we have log base 10. Log base 10 is the common log. So I really don't have to have the 10 in there. I can just say log of something is equal to log of 9x. So therefore, the other argument has to be 9x to be able to match what we have on the right. So therefore, 10 raised to the log of 9x is just going to be equal to 9x. Part F, natural log of 1. We have the implied base of e. So this is going to say e to the something needs to equal 1. And there's only one exponent that we know that will make the answer become 1, and that is an exponent of 0. So therefore, the natural log of 1 is 0. One final example, log base 3 of 81 minus log base pi of 1 divided by log base 2 square roots of 2 of 8 minus log of 0.001. So this is not just a single logarithmic expression or a single exponential expression. This is some sort of ratio involving the difference of two logs. So what I'd really like to do is kind of isolate the individual log statements within the overall ratio here and look at them individually. So for example, the log base 3 of 81. If I look at that on its own, then I can do what I was working on up above by setting that one expression equal to a question mark, and then saying that 3 to the question mark has to equal 81, and then that tells me that my answer would have to be 4. So right here where I have log base 3 of 81, that's really equivalent to 4. And then I do the same thing with the other logs. If I do that with log base pi of 1, that's going to be pi to the question mark needs to equal 1. Well, that means the exponent has to be 0. So then this is going to be 0 for log base pi of 1. My numerator is really just saying 4 minus 0. Now do the same thing for the denominator. I have log base 2 square roots of 2 of 8, and I want that to be equal to something. So then I would have to take the base 2 square roots of 2, raise it to some exponent until I get the answer to be 8. Now this one may not be as obvious. You might need to use your calculator to play around with it, figure out what the appropriate exponent needs to be. As it turns out, the appropriate exponent is 2. So that log can just be simply represented by 2. And then we'll do this one more time with log of 0.001. And while you've got your calculator, why don't you just type that in? And if you plug that into your calculator, you will find that this statement is equal to -3. So we have in the denominator the statement 2 minus -3. Numerator simplifies to just be 4, denominator simplifies to be 5, and the answer simplifies to just be 4/5.